Nvidia's DLSS 3.5 with frame generation is like actual magic.
You can take a game that's at 27 FPS and take it all the way up to 230? That's fucking insane.
Oh, you clicked on this video thing that was gonna hate on frame generation. Nah, I actually love it.
Do you like my jacket?
Frame generation in video games is a technology that takes two real frames and then tries to interpolate the difference between them and then make up that gap to make the game feel smoother at a higher frame rate. Now, Nvidia launched frame generation with DLSS 3 back in 2022 with the RTX 4090. And then AMD quickly followed up with an announcement that they later actually launched FSR frame generation way into the future of like early 2024. And then beyond that, in December of 2024, Intel also released their frame generation. And now just in January of this year, Nvidia introduced multi-frame generation, which can do ×3 or ×4 frame gen.
Latest generation of DLSS also generates beyond frames. It can predict the future.
And this came out with their new 50 series graphics cards, which are the only ones that are capable of this apparently.
With the Blackwell architecture, the display engine was improved to leverage flip metering.
And with this being integrated into games, it uses data like motion vectors or even AI to help calculate the frames and interpolate that difference, which honestly has some really good image quality. Like, look at this. I mean, it looks like it's running at 120 FPS. I recorded this at 120 FPS, slowing it down for you so you can see it. It looks pretty damn good. And I find myself using it from time to time because of how it looks, how smooth it makes the game feel. It genuinely is a pretty damn good experience. And frame generation allows you to achieve high frame rates, which is great at a time when high refresh rate monitors are becoming more and more available. Let's say here's 165 Hertz. Yeah, I mean, that's kind of hard to get in a lot of games. So using frame generation is a lot easier. We all know that bigger number means better person, and bigger FPS number also means a better gaming experience. I mean, shit, 600 frames in Stellar Blade, that is a lot of freaking frames. I don't even know who's gonna use all those frames, but it's pretty good. Which would make it really weird if any of these companies, use this technology to, it's getting kind of hot with this leather jacket on, to like deceive us or anything. They would never use this for marketing purposes maliciously.
With the Blackwell family RTX 5070.
Damn, so shit, you just wasted your fucking money. This now it's for it's $500.
This is meant to be equal to a 4090.
Yeah.
Obviously, this is a massive lie, and it's a damaging one that hurts features like frame generation by weaponizing it to mislead gamers. In reality, the RTX 4090 is actually on average 63% faster than the RTX 5070 across our 16 game sample at 1440p.
A post here from Nvidia saying that you get 50 times the performance for tens of millions of gamers using their 5060 Ti versus a GTX 1060, which was a great graphics card. But you turn on DLSS and use frame generation and you're gonna get a lot more frames. So let's hop in again with the RTX 5060 and see how that holds up. We're at 1440p at DLSS qualities at like 1080p rendered up to 1440p. We're getting about 60 FPS in this title. All right, so like that's decent performance. Now let's go ahead and turn on frame generation. Turn it on 2x mode. I think it'd be 60 times 2. I know a lot of math, but that should be 120 FPS. But we're only getting 94, which isn't nearly as much as you would think. And well, we can go up to 4 times frame gen. Maybe we can get 4 times the frame rate. You'd think this would be 240 FPS on the 5060. We're getting more like 160 FPS, not anywhere close to 4 times 60. Let's hop over to another game because maybe this one just ain't working right. In Stellar Blade now, we're at about 87 FPS, just standing still. We're at 1440p, pretty decent performance already, but maybe you have a really high refresh rate monitor and you want to get a higher frame rate because it looks smoother. Go ahead and do 2x. We would expect over 160, 174 FPS would be double, and we're only getting 124 here, and we can go to 4x as well. So let's do that. And you would think you would get like over 320 FPS, but we can only get a mid 190. But you also might have noticed this little box at the top of the screen that's also showing more FPS values. And this little box has opened my eyes or completely confirmed my suspicions that was going on with frame generation in general. This reveals everything. I thought like when you didn't get 2 times the frame rate, that it wasn't throwing away your real frames to put more generated ones in it, but it's actually always doubling or tripling or quadrupling your frame rate, reducing your real performance in latency and responsiveness, and in place putting in generated frames. You're probably like, what is this box? Where is it from? What does it do? Well, this is the new built-in Steam Overlay, and Valve, they can't be stopped. On today's modern systems, frame rate has been complicated by the introduction of frame generation technologies like DLSS and FSR. If a user has a capable GPU and has frame generation turned on, then most software will see FPS as a number including the generated frames. This is correct if you think about just the smoothness of the video and how frequently the monitor is updated. However, this is incorrect if you care about actual game frames, which do other work like process input, handle network updates, perform collision detection for models and projectiles, etc. Frame generation can't help with these things like input latency, but it can make things look visually smoother on today's high refresh rate monitors. So Steam is building in this new overlay that shows you the after frame generation performance, but then also the input frame rate that it's getting before that, which can affect the way that the game feels even if it looks pretty damn smooth. So this overlay is extremely important and reveals tons of information in the problems about frame generation, not to mention some of the issues I've also discovered with things like the latency, how they try to hide this stuff from us. So let's dig in to frame generation. Obviously, the RTX 5090 is a $3 bajillion GPU, so I would hope that it could handle frame generation literally the best out of any other graphics card available. As we go through these, I want you to take note of some of the values that are on the screen. Obviously, I have a bunch of stats up on the top. Some of the biggest ones is this average performance on each one. This one is the frame generated performance, and then this other one over here is the base frame rate that it's frame generating from. And then this percentages that are below all of this are the percentages compared to the original frame rate on the native side or on the left side of the screen, whatever that test is. So this is native versus 2 times frame generation with DLSS on the RTX 5090. So the best GPU in the world, in Black Myth Wukong with 2 times frame gen, loses about 20% of its base frame rate when turning it on, which isn't amazing, but I guess that's the best we can get. Now we hop over to Cyberpunk 2077, it loses 27% of its base frame rate. Now obviously you're getting quite a bit of more extra generated frames, which will increase the smoothness, but you hop over to path tracing and you only lose, I guess, 19% of your base frame rate in this case. In Assassin's Creed Shadows, it only loses about 14% of its base frame rate, which isn't really that bad. Now the RTX 5090 is an extremely fast GPU, which actually gives it an insane advantage compared to a lot of other ones, and that's because it is CPU limited. Even though I have literally the fastest gaming CPU in the world in this PC, the 9800X3, the absolute ripping fast CPU, the 5090 can still outpace it some of the times. And this shows up in the amalgamation of stats that I have at the top of the screen. This is a Frankenstein from a bunch of different overlays I had up on screen when actually doing the test. There's a GPU busy and then a frame time metric, which will have different values some of the time. The GPU busy timer is basically how long does it take the GPU to render a frame, and then the frame time is how long does it take the CPU to render a frame. And if they are misaligned, if the CPU is taking longer to render a frame than the GPU, then you're going to be CPU limited. You catching the drift? And basically this little percentage point that's next to those is tracking the deviation percentage. So if this percentage goes up, it means that the CPU is taking longer to render than the GPU. Basically, if you see this percentage not being 0 or like 1 or 2 maybe, then it's probably gonna be CPU limited in the game. And CPU limits really benefit frame generation.
DLSS 3 can generate new frames independently of the CPU, which means that we can get up to 2x speed up even in CPU bounded situations.
In Last of Us Part 2, we're getting over 200 FPS on the 5090 with the 9800X3, but we're still CPU limited. You see that deviation percentage? And that leads to a weird conclusion. We're still losing 15% of our base frame rate by using frame generation, despite it being CPU limited. And the same thing happens in Stellar Blade. We get a little bit CPU limited. The same thing happens in Cyberpunk 2077. We get a little bit CPU limited when we're not using ray tracing. And if you take a step back and look at the average of all of these tests, the 5090 loses just by ×2 frame gen, is losing about 20% of its frame rate to turning it on. So with this graphics card, you can kind of stomach that because you have a lot of base frame rate to play with. That's really not that bad. And maybe it'd be worth getting 59% more generated frame rate on average. Now we can turn on ×4 mode and the situation starts to get a little bit crazier. In Doom the Dark Ages, we're losing about 33% of our base frame rate, which is pretty significant, not gonna lie. And it's much more than we were losing before, about 20% on the ×2 mode. Last of Us Part 2 is a similar situation, 31% of performance loss. We're still base frame rate of like 150 FPS, the 5090 is absolutely crazy. But I think it's interesting that even with the CPU limit, we're still having this issue of losing frame rate, even on a 5090. I'm not going to drag this on, but again, in Marvel Rivals, 37% worse on the base frame rate. Still a lot to play with, but a very significant performance impact. Obviously, the generated frame rate is absolutely massive. It's not quite ×4, as we see with the ×2 mode we just went over. It's actually about 2.7 times more frame rate, not performance. They like to say performance, but it's about 2.7 times more frame rate than the native. Then the base FPS takes about a 32% hit on average, which also increases the latency in a lot of these titles because you don't have as much base frame rate to play with. So it's crazy to me, especially with ×4 frame gen. Everything has every advantage in the books, and it still struggles in a lot of these titles, which is a really bad sign for maybe some of the other graphics cards, right? So frame generation is marketed as a silver bullet that is going to be an absolute game changer on every single graphics card. And that's why I wanted to test it for myself. This is why this video has taken so long. You might have saw that I haven't uploaded in like over a week. I tested 8 graphics cards to see how do they perform with frame generation. Something I do want to set straight is how did I calculate the averages here? Obviously, I'm using the Steam Overlay. I usually use a program for my tests that actually takes the rolling average of a test, but I can't really do that with a Steam Overlay. It just kind of shows you what's happening in real time. What I did is I looked through the benchmark and I tried to find a point in each benchmark that reflects the average of the entire thing. And then what I did is I captured that frame of every single test. So everyone is measured at the exact same point in time, and that's the value that you're seeing at the top of the screen. So I want to warn you that this isn't the most accurate way of testing this, but I did absolutely try my best. I'm trying to reflect that for you guys. So here on the RTX 5070 Ti, this graphics card is about $830 now. So it's still very expensive. Not 5090 prices, but you know, I wish we could generate money like we can generate frames nowadays. So you'd hope that it could handle these features that are marketed for the card itself. Cyberpunk ends up being pretty similar to how the 5090 was. It is 26% slower in the base frame rate, which only leads to about 49% more with the frame generation, even though it's supposed to be ×2. Interesting thing in Doom the Dark Ages, and this probably skews the numbers a bit because for some reason the base frame rate with frame generation was higher. I have no clue what I could have possibly done wrong. So I guess that's something, which actually leads to your ×2 being even higher as well. So maybe I messed up with something. This is a path tracing mode, by the way. In Marvel Rivals, you're losing 27% of your base frame rate, affecting your latency, but you do get over 200 FPS as the generated frames. So with frame generation ×2 mode on average, I found that the 5070 Ti gets about 62% more frames using 2x frame gen. So it's not 2 times, it's like maybe 2/3 times. And you also lose about 19% of your frames on average at the base frame rate, which affects your latency and such. Now we hop over to the ×4 mode. You're getting about 171% more frames, but you're losing 32% of your frames to get there. So it's not the best thing in the world. Just by going 2 to 4 times, you're losing 16% of your base frame rate, and you're only gaining 68%. It should be double in this case. Let's hop over to a slightly more affordable graphics card, the RTX 5060 Ti 16GB. This is the 16 gig one, probably the model that most people should buy. About $430 right now. It's actually coming down to MSRP, which is exciting. It's a decent card at that price point. Now on the 5060 Ti, this starts to worry me a little bit because as you go down the product stack, these cards have less and less AI performance. The newest model of DLSS 4 uses AI for both the optical flow acceleration. I know these are big fancy words, but basically you need AI to do that and also to generate the frame itself. So you need quite a bit of AI, especially as you go up the generated frame spectrum, you know? So the 5060 Ti might start to struggle a little bit more. It seems like it's able to handle it, at least with the higher VRAM capacity. This does have 16 gigabytes. And we go to frame generation just 2 times, we can get about 68% more frames, and we're only losing about 16% of our base frame rate. Now we hop up to ×4 mode because this is a 50 series card. It can also use ×4 despite it being on the lower end. It does start to struggle a lot more ×4, more looking like 30 to almost 40% loss in your base frame rate. You can get 180% more frames, which is not actually that bad, I guess. I mean, it's not 4 times, and you're losing 30% of your base frame rate, which is a pretty decent hit. And as you go down on these lower tier cards, then it's gonna be dropping the base frame rate to a range maybe that won't be playable in whatever game that you have it in. Maybe that latency is gonna be too high that it's gonna feel like you're playing the game through a pool of gelatin, not really feeling like you're actually connecting with the game, especially with things like a keyboard and, you know, a mouse. These are very like one-to-one inputs for your game. You move the mouse and you expect to move that far, and if it isn't moving like that, it's not like a controller. Like, you feel that latency. Then you could use things like super resolution, like DLSS, super resolution, to try to increase your base frame rate by rendering at a lower resolution. Then it's like, at what point should you be rendering at a lower resolution? It's also gonna look like you're swimming in Jello too, or you smeared Jello on your screen or something, because it could look really blurry and not at all what the game should look like if you have to drop too low. So as you go down the product stack, the frame generation becomes maybe a tougher and tougher sell, despite it being probably the main marketing point for these cards. That brings me to the RTX 5060. Now this card is $300 and it has 8 gigabytes of VRAM, which is a bit of a problem because other ones had plenty of VRAM for this type of stuff, but 8 gigabytes is really pushing it in a lot of games. Just look at Hardware Unboxed. They just talk about that every day, apparently. They can't stop.
I would love to see like the notebook of a therapist who talks to you, so it would just be like VRAM. It would be like 100 pages of VRAM.
We look at ×2 mode on the 5060, and Last of Us Part 2 only loses 28%, which does actually knock the base frame rate down under 60, which you could argue if it's responsive enough for you, because we're getting up into almost 40 millisecond territory. Hop over to Marvel Rivals and you're losing 30%. Remember, this is just the ×2 mode, and Marvel Rivals isn't even a very VRAM intensive game. And this is the type of GPU price range where you might be tempted to use frame generation in this game, particularly to get a higher frame rate, but that's not really the case. In Stellar Blade, you're losing 28% of your base frame rate, knocking you down to 60, so you could argue that this would be decent. Although I did notice that the frame time spikes, I don't have my full list of stats on this, but frame time spikes are a little bit more aggressive when you use frame generation because it's pushing the VRAM. It only gets, and this is real bad, it only gets about 28% more frames when it's supposed to be getting, you know, 2 times or 100% more frames. It's barely getting anything. It makes me feel like I'm going just a little bit crazy, you know? And you're losing 31% of your base frame rate, trading that for these generated frames that are barely even higher than your base frame rate. But this is also a 50 series card, which means that it has access to ×4 mode. I bet this one will go so much better, right? ×4 is looking at a lot more like ×2 mode on the 5060 because it's getting it's getting twice the frame rate. It's 110% on average, and you're losing 39% of your base frame rate. This drop off, this fall off for the 5060 is legendary. It's a legendary fall off. And partly why these numbers are really bad on the 5060 is that VRAM capacity, especially in a game like Doom the Dark Ages. For the life of me, whenever I try to get this to run in the game with Frame Gen on an 8 GB graphics card, it just seems to absolutely break. And you actually get less frames by frame generating, and it even seems like the Steam Overlay that's up top gets completely broken. It's not even saying that Frame Gen's on, despite everything I've tried to get this to work. It doesn't even say it's on. It's like, why is the frame rate lower? Like, it's literally like you turn on Frame Gen, your frame rate gets cut in half. You might as well just play native performance in this game. So this is definitely one of the reasons why numbers on the 5060 are drawn down so much across the averages. But you know, it's a realistic scenario that you'd run this card in, and it just doesn't work in that game. And if you just want to use it in some other games, say like Marvel Rivals, I mean, it's a competitive game and frame generation increases latency, so I don't know why you would use frame generation in this title. Using ×4, it actually cuts your frame rate almost in half, like your base frame rate. Why would you want to use it in this game? Your latency is so much worse. Yeah, it looks smoother, but it doesn't feel smoother or more responsive to play, especially in a game like this. The same type of thing happens in Stellar Blade. You almost get half of your frame rate cut out just by turning on frame generation. It doesn't really make sense to use at all. And this is the combined thing of the limited VRAM capacity on the 5060 and then also the limited AI performance on the card, despite 50 series having a lot larger AI increase on this generation. It's like twice as much as 40 series. And that leads me across the board. 50 series from Nvidia struggles quite a bit with a lot of these games. Like frame generation ×2 is not ×2. It's more like 2/3 maybe if you have enough VRAM. And then ×4 is maybe more like ×3. And that brings me to 40 series graphics cards. Do not have access to DLSS multi-frame generation with ×3, ×4 because apparently Nvidia was like, it just doesn't work on it.
Flip metering.
So not even on the RTX 4090, which is still a monster graphics card today, that can't use multi-frame gen. So if you use it with just DLSS frame gen ×2, in Cyberpunk you lose 25% of your base frame rate, in Last of Us Part 2 you lose 24% of your base frame rate, in Black Myth Wukong you lose 18% of your base frame rate. These are just a few of the games that I tested. You can get 60% more frames. It's not 2 times the frame rate, even on 40 series most powerful graphics card, and you lose 20% of your base frame rate on average. Hop over to the 4070 Ti Super, which is a pretty high-end graphics card, 16 gigabytes of VRAM. And Doom the Dark Ages, this one's actually pretty good. You're only losing 13% of your base frame rate, which does give you 173% for 2 times frame gen. In Last of Us Part 2, you're losing 25% of your base frame rate, still very high at over 100 FPS. In Cyberpunk, you lose 24% of your base frame rate. So on average, it works out you gain about 62% with the generated frames, and then you lose 19% of your base frame rate. Moving on to the RTX 4070, in Assassin's Creed Shadows, you lose about 29% of your base frame rate, which does knock you down to 48 FPS. That's not the best experience. In Cyberpunk, you're losing about 28% of your base frame rate, and that does increase your latency a good bit. I've been wanting to show Last of Us Part 2 because it kind of highlights this. It seems like frame generation performs worse in this game. You're getting 28% loss on your base frame rate, which is pretty significant. And that makes the actual generated frames much lower than you would expect it to be. And that plus some other tests that I ran leads to an overall average of 61% gain with the frame generation ×2, which it should be 100%, and then you're losing 20% of your frame rate. So those ones are pretty similar. Across the stack, it's about 60% more frame rate. But you know, hop over to RTX 4060. This card has 8 gigabytes of VRAM, which as we talked about with the 5060, probably means it's going to struggle in a lot of games. And on average, across a lot of these titles, it only got 35% more frames with frame generation. ×2, it's supposed to be 100% more, and it's getting 35%. This just doesn't make sense to use on this card. And it's being marketed on it, you know, that it's super useful. You're losing about 27% of your base frame rate. Honestly, most of the time on the 4060, I don't recommend turning it on. Obviously though, a lot of this average is brought down by that one test, so we get less frame rate in Doom the Dark Ages. It's something to take into account, but this is a situation you have to tinker with to even try to get frame generation, the feature that you paid for on RTX 4060 to work properly. But really on every card out there, it affects the responsiveness. You lose your base frame rate. Is that worth it to you in certain titles? I'm not 100% sure. It depends game by game. What is your base frame rate? And you can use this Steam Overlay to really help you figure out like, oh, do I want to be in a base frame rate range about 50 to 60 FPS or something like that? And Nvidia recommends that like 50 milliseconds of latency is okay for the graphics cards to play on. That's a good gaming experience. That's completely up to you though, because 50 milliseconds can feel pretty unresponsive to me a lot of the time. And I think a lot of you guys could also pick up on it, but maybe it won't bother you. It depends on the game. Literally, like Marvel Rivals, it'd be like playing you're at 100 ping and then somebody else is at 50 ping. It doesn't seem like a great experience. Also, if you've been curious about FSR frame generation, I haven't really been talking about it that much in this video, but I did test it. It results in about the same frame rate dips. The Steam Overlay still works with it. It is harder to measure the latency with this because it doesn't have an integrated tool like Nvidia graphics cards do. You'd have to use like a slow motion camera or some shit. I ain't doing all that, I ain't gonna lie. But it's about the same. The latency. Is the game responsive enough to play? Because frame generation will always add latency. Nvidia and a lot of game developers have also found out ways to mitigate this or make it seem like frame generation is faster than it really is. Now I'm going to show you this by being in Stellar Blade again. You know, we were talking about how like 50 milliseconds of latency is what we should be doing. We don't have frame generation enabled right now, or really anything. We're just at native 1440p. Our latency is actually pretty high. We're around that 50 millisecond mark, which getting like, you know, 80 FPS, you'd think you'd be able to get better than that, which is where technology like Nvidia Reflex comes in. We're just going to turn it on and our latency is going to reduce. We're at like almost 50 milliseconds and our latency literally just got cut in half. Now, Reflex is Nvidia's version of this technology. AMD also has a version of this technology called Anti-Lag 2. They had issues with Anti-Lag Plus in the past, but we're not going to talk about that. But what Reflex basically does is dynamically cap your frame rate so that you get the absolute tightest latency. I'm not going to go into the in-depth explanation of it, but that's essentially what it does. So right now we're getting about 24 milliseconds of latency, and you can also experience this by capping the frame rate yourself. So we head back into the graphics and we turn back off Nvidia Reflex, but then instead we turn on some kind of frame rate cap, which I think there's one in here. So we go to target frame rate. We're going to cap it at 60, which we're getting 80 FPS before, but I'm going to show you that you actually get better latency at a lower frame rate by capping your frame rate. We capped it at 60 FPS. We're getting like 28 milliseconds of latency. Really decent latency. You know what I mean? So if you want a responsive gaming experience, capping your frame rate is a really good way to go. Now you still want the smoothness and stuff of a higher frame rate, so you might want to still go higher, but you know, capping your frame rate can be pretty good. And I made a whole video about this if you want to check it out a little bit more in depth. So by default, with frame generation, Nvidia knows it uses more latency. They always have Nvidia Reflex enabled by default. And you'll see in some marketing materials that they'll say that your latency with frame generation on is actually lower than at native. And technically speaking, it is, but you could always turn on Nvidia Reflex at native anyways. You don't need frame generation turn on Reflex. You could always use this no matter what, which is one of the strategies that a lot of developers do, or even Nvidia maybe tells them to do. I'm not sure on the intricacies of how this works out, but some games don't have an option to toggle Reflex on and off. Yet they have Nvidia frame generation or DLSS frame gen, so it should have access to Reflex technology, but in a game like Assassin's Creed Shadows, they don't allow you to turn it on. Nvidia frame generation should increase your latency, but if you turn it on in Assassin's Creed Shadows, it actually decreases your latency versus native, because at native, they don't have Nvidia Reflex enabled. So really sussy situation. This also used to be a thing in Black Myth Wukong. This is kind of like an Nvidia sponsored title. I'm not sure if they exactly like paid them, but they at least worked with Nvidia to make Black Myth Wukong. So it kind of make you a little sussy on what's going on here, because at least originally when the game came out and for almost a year after it did come out, you couldn't enable Reflex on your own at your native frame rate. Because as you see, the latency is actually pretty high despite the frame rate also being pretty high when I was testing it out here. If you cap your frame rate, you will get improved latency. So much so that I actually preferred to play the game at 60 FPS capped because the latency felt pretty bad in this game. But you had no option of fixing Reflex in it, even though Reflex was available in the game through frame generation. And then all of a sudden, your latency feels better. The game feels more responsive with frame gen on, and that gets you into a scenario where some people are saying that frame generation feels like magic. And it's all because of the manipulation that's making you feel like it's better than it is. They updated this to put like multi-frame generation in the game with DLSS 4. It's still in freaking Chinese. Right now, frame generation is off. This is, I think, like a Chinese character for clothes or something. And here you can change the reflex mode or the low latency mode. So right now I'm going to turn it off. As you see in the game, we're actually getting like 70 milliseconds, 80, almost 90 milliseconds of latency. And then if you turn on this mode, the latency to reduce quite a bit by turning on latency reduction technology automatically. Now we can get 40 milliseconds. Again, this isn't to say that frame generation doesn't have its benefits. Obviously, you can get some high ass frame rates, which can be pretty damn good, especially with high refresh rate monitors. And you can do this at the same time without dropping your in-game settings or dropping your resolution. Really, the only thing you're compromising is a little bit of image quality, which isn't as bad as dropping the resolution in the game, or I would say turning down the settings in the game in quite a few cases. Then you're also dropping the latency, which may or may not matter at whatever frame rate you're in or whatever type of game you're playing. It actually might be better to see a smoother experience than a more responsive experience. All at the same time, it does this in a very smart and efficient way, which is like a working smarter and not harder type of thing, which, to be honest, you would think, oh, that's a pretty big W for everybody at the end of the day. But you could do from 60 FPS up to 240 or something like that. But if you really slow down that footage and zoom in on some things, then it does break up quite a bit. But at the end of the day, you know, you zoom out and you're in your full speed and everything, it doesn't look terrible. Now, I wouldn't really recommend using Frame Gen in Marvel Rivals. It doesn't actually make sense in that game. But I gotta give them that, like, it can look pretty good. What I hate, though, is using it as a marketing crutch. Using it as an excuse for not improving the performance on a generation of GPUs that much. The actual raw performance isn't that insane from each generation to generation here. It's been very, very mild. If you generated all of your money, you know, if you went from $2 up to $4,000 or something, and you had enough money to buy a 5090, yeah, you can win more on it. If you're already at a good frame rate, is even better. You know what I mean? You're going to be able to max out your monitor refresh rate, even if you have like a 500 hertz monitor or something. I bet even in single player games, you can max out that refresh rate. Do you need that many more frames? I don't know. At a certain point, it becomes kind of useless. You can do that on a 5090. Go down the stack, it becomes less and less useful because the performance hit becomes so great. It was really interesting to dig into this on a bunch of different graphics cards to see how it stacks up, and then also, you know, use this overlay to its fullest extent. So hopefully this helps you out, but that's been it for me. Let me know what you think in the comments below. I'm gonna see ya in the next video. All right, peace.